All right, welcome back, everybody. Today we are going to be talking about how we solve by factoring. Now, this is actually very similar to what we were doing yesterday. So today, what you're going to see is a variety of different techniques or approaches that we could be using. First thing I want to show you is that when you see a problem like this, we don't want to factor whenever we have stuff on different sides of the equation. We really want it to be equal to 0. So what we're going to do is we're going to move the 60 over to the other side using subtraction. When we do that, we're going to be left with this. Now, as we look at this and we try to factor and we start to think about it, one thing we should notice is that we could pull a 5 out of each of these terms. So if I divide a 5 out of each of these terms, that would leave me with a squared plus 1a minus 12, all equal to 0. Right? So that's always the goal. We're trying to factor and make this into something that's multiplied. Now, this part we can factor some more using our x method. So 1 times negative 12 will give us a negative 12. We'll have a positive 1 on the bottom. We'll have our 1a and our 1a off to the sides. And then we just need to think what numbers multiply to be a negative 12 that add to give us a positive 1. And that would be a positive 4 and a negative 3. So once we have those numbers and we have that all in place, we know that we can rewrite this as 1a plus 4 and 1a minus 3. The 5, of course, is going to drop down in front. And that's equal to 0. Now, we do need to solve this as well. So we need to figure out which value of a makes this actually equal to 0. Remember, since these pieces are being multiplied together, you just need to look at each piece. This first piece, 5, is a constant. It doesn't change because there's no a that's hooked onto it. The second piece, 1a plus 4, changes depending on what a is. So I'm going to rewrite it as a plus 4 equals 0. Now notice how I didn't put the 1 in there. You don't have to put that 1 in there every time. For this other expression, we're going to have a minus 3 equals 0. Now we just need to solve. Minus 4 from both sides, we get a equals a negative 4. Add 3 to both sides, and we end up with a equals 3. And we're done. Right? So that's our process. We always try to get everything onto the same side. Right? That maybe be like step 1. Step 2, factor out a greatest common factor. Step 3, factor more if possible, and then finally solve. So here's another problem for us to consider. So in this situation, we want to try to get everything onto the same side. Now, officially, it doesn't matter which side you get it onto. I think I'm going to try to get it all over onto the left. So I'm going to add 25b to both sides. Now that's going to leave me with negative 10b squareds plus 25b is equal to 0. Now in this situation, what we want to do is we always want to look for a greatest common factor. So looking at this, we notice that we can pull out, how about negative 5 out of each of these numbers? The reason I'm pulling out a negative is because my leading term here is negative. So I can pull out a negative 5 out of each of those, but I can also pull out 1b since they both have at least 1. So factoring that out, this is what I'll be left with. Negative 10 divided by a negative 5 will leave us with a positive 2b. Positive 25 divided by a negative 5 will be a minus 5. And we won't have any b's there because we pulled it out. So once we arrive at this point, then what we need to do is we need to solve. So we have two things being multiplied together to equal 0. So we're going to take the first one. This one has a b, which is why we care about it, and set it equal to 0. And we're going to take the second one and set it equal to 0. Now we just want to solve. To solve the first one, we divide both sides by a negative 5, and we find out b is equal to just 0. To solve the other one, we want to add 5 to both sides. You're going to be left with 2b is equal to 5, and dividing by 2 on both sides, we find out b is equal to 5 halves. And we're done, just like that. Moving on to problem number 18. If you're looking at problem number 18, we should first notice we have stuff on different sides, so let's pull it all to the same side. So I'm going to subtract 50x from both sides. That's going to give me 18x to the third minus 50x is equal to 0. Just like in every other problem, at this point, we're looking for a greatest common factor. So, in this situation, it looks like we can divide a 2 out of both numbers, and since they both have at least one x, I'm going to be able to pull out an x. So when I do this, that's going to leave me with 9x to the second minus 25, or 25, just 25, equals 0. Now, when I look at this, what I want to start noticing is when I have perfect squares here. Like we've talked about a couple of times now, there's a pattern when both of those are perfect squares and they are being subtracted. And what you need to do is just take the square root of both of them. So the square root of 9 would be 3. So I'm going to have 3x. And the square root of 25 will be 5. So those will be the two numbers that I will factor with. And then when I look at that middle term, as long as it's a negative, then I can make this into a plus 5 and a minus 5. And that part has been factored more. And my 2x drops down. Now, in this situation, we have three things that all have an x and are being multiplied together to equal 0. So we need to do three mini equations. So 2x equals 0, 3x plus 5 equals 0, and 3x minus 5 equals 0. So to solve the first one, divide by 2. 0 divided by 2 is still 0. So that is our first answer. Then we go to our second answer, or our second equation, minus 5 from both sides to start. I'll get 3x is equal to a negative 5, and then I'm going to divide by 3 and divide by 3, and x will be equal a negative 5 third. Now for the last one, we're going to add 5 and add 5. I'll get 3x is equal to a positive 5, divide by 3 and divide by 3, x equals 5 thirds. So all three of those are going to be your answer to this problem. Let's look at problem number 7. I think we only have two more left to do. So again, in this one, notice how everything's on the same side already. So we're going to look for a greatest common factor. In this one, we can pull a 2 out of everything. After pulling out that 2, we notice that this middle part should probably be factorable. So 1 times 16 puts a positive 16 up top, and we'll have a positive 8 on the bottom. We'll have 1x here and 1x here. Now we're just looking for two numbers that multiply to give us a positive 16 that are going to add to give us a positive 8. And how about a 4 and 4? So when I come over here, my first factor will be 1x plus 4 and 1x plus 4 equals 0. And the 2 is going to drop down in front. Now officially, we have three things that are being multiplied together here to equal 0. But this one doesn't have an x, so that one's never going to change. So I'm going to have my equation 1x plus 4 equals 0 and 1x plus 4 equals 0. Now, one thing you might notice is that these two equations are the exact same. So if they're the same, let's not reinvent the wheel here. We don't need to solve it twice. We're just going to solve the one. So to solve this and get our answer, we'll subtract 4 from both sides, and that will leave us with x equals negative 4, which will be our only answer. Looking at problem number 9, this will be the last one that we're going to work together. Here's what we're going to do. First off, we have stuff on two different sides of the equation, so we are going to move this 6 over to the other side by adding it. And that's going to get it equal to 0, which is what we want. Now, once we get to this point, I want to look for a greatest common factor, but 3, I can't pull anything out of each of these three numbers, right? 19 is kind of the troublemaker there. So if I can't pull anything out, then what I'm left to do is try to factor this. So I come over to my x. Remember, I always take whatever number's in front, and I multiply it by this one to get my top. 3 times 6 is going to give us 18. I'm going to get positive 19 on the bottom. Now, since this is 3, it's going to be 3w and 3w over and over. Now we just need two numbers that multiply to give us positive 18 that add to give us 19. And that would be 18 and 1. Both of those are positive, of course. Now, before we sit there and write out our factored form, remember we need to reduce the fraction. So this would be 1 over 6. So my factored form of this will be 1w plus 6 times 3w plus 1, and that's going to be equal to 0 because the original was equal to 0. Now at this point, you just need to solve. So w plus 6 equals 0, and 3w plus 1 equals 0. To solve this, I'm going to first start by subtracting 6 from both sides. I'll get w equals negative 6. And on the other side, I'm going to subtract 1, 3w equals negative 1. And then I'm just going to divide by 3 and divide by 3. And look, w is equal to a negative 1/3. And we are done. With that being said, I think that gives you a pretty good example. I believe all the problems are going to be fairly synced up, meaning whatever I did on like the example problem will be similar to what you need to do on your homework problem. Thank you guys for watching the full video. If you have any questions, please be sure to reach out and ask. I hope you are well. Thank you.